Hi, I'm Keith Pembleton from the University of Southern Queensland and also from the APSIM Initiatives Reference Panel. Today, for our next training, or APSIM training video, we're going to look into climate change. Now, this is a more advanced topic, so if you haven't completed modules 1 to 5 of the online training material, it's highly recommended you do so before jumping into this topic. So let's get started. So we'll get rid of the picture of me so we can fully see our user interface, which is right here on the screen, and it's opened up with our most previously saved simulation. Note here that this is, I've got the chickpeas simulations from the previous module. And so today we're going to tackle a climate change scenario. So there is conveniently a pre-existing climate change scenario under our new simulations button. So click that in the top left-hand corner, scroll down in the out of our example simulations, and we'll find one here called Continuous Wheat with Climate Change, and open this one up. And there's a number of components in this simulation tree. So there's one here which you may not have seen before, called the Climate Control Manager. Note how it's not placed in the Manager folder in the paddock. There's managers there. This manager here actually perturbs our climate file, or our MET file, which is loaded through the MET node. And so if we click back on it, you see here it changes the maximum temperature, increases by 1. It decreases our minimum temperature, or increases our minimum temperature by 1, decreases our rainfall by 10%, and sets an atmospheric carbon dioxide concentration as well. And we can set the date range this happens within, so we can actually create multiple climate controls for different periods of the year, if we so want to. The other components of the simulation there you should be familiar with, because we've covered them previously in the previous module. So we've got a soil component, we've got a surface organic matter component, fertilizers there because we've got a fertilizer rule in our manager folder. We've got our wheat crop, we've also got a number of managers, and we've got our output components as well. Now, the first thing we're going to do, like we always do, is save our simulation with a new name. So click Save As and navigate to wherever you're saving your APSIM training simulations to. And this one we're going to call Climate. So just save it like that. Now, we're going to change our start date in our simulation to the 1st of January 1970. Leave our end date as the 31st of December 1989. This gives us a 20-year simulation run. And if you noticed in the manager folder, we didn't have our reset rule. So in our previous module, we introduced the concept of annual resets, and we're going to use that rule in this simulation. Because we are running a long-term, a 20-year simulation run. So you'll find the reset manager in the manager toolbox, and it's under the manager common tasks folder. I'll just expand that out so we can see the full name of it. Scroll down to the reset water, nitrogen, surface organic matter, and phosphorus on fixed date. Bring it up, or select it, drag it, and place it into the manager folder. Okay, and it's placed at the bottom of our manager rules. Now remember, this manager is very picky about where it's placed. It needs to be at the very top of the folder. So just right click on it and select move up, and keep doing that until it's at the very top of all our manager rules. And we'll set a reset date to the beginning of the year. So the 1st of January. Make sure that your dates match exactly as I'm putting in on the screen here, because APSIM is very picky about the date formats. We need to tell this manager what the name of our soil module is, and in this simulation, note here it's called soil. So we'll select soil. Make sure that we select the surface organic matter module, the surface organic matter module, and then make sure we've got reset water, reset soil nitrogen, reset surface organic matter set to yes. We can leave reset phosphorus as no, because we don't have a phosphorus component in this simulation. Now if we expand out our soil and click on initial water, You'll notice here that our initial water is set to 100% full. We'll leave it that way. We've got in here a number of different crops already, and wheat is somewhere right there. So we've got our wheat parameters already. And we've also got some initial nitrogen set up through our soil profile. And we'll just leave our soil profile the way it is for the moment. And we'll also leave our surface organic matter profile, or surface organic matter pools, the way it is at the moment. We'll leave our sowing rule the way it is set to. Our fertilizer rule, which is putting this all on at all our fertilizer on at sowing. So we're putting it on 150 kilos in urea nitrogen whenever the wheat crop is sown, and we'll also leave our harvesting rule the same, so it's harvesting wheat. In our output files, notice here we're requested a number of outputs already, and we'll leave them the way they are. We've got yield there, and we've also got biomass, grain protein, grain size, and extractable soil water, and the reporting frequency is at harvest as well. Now we need to set our climate scenarios. So what we're going to do before we set a climate scenario is rename our simulation from continuous wheat climate change. We'll actually name it with the scenario we're going to create. And we're going to call this one the 350 parts per million simulation. So this one here, we're going to set our atmospheric carbon dioxide levels to 350 parts per million, and we'll also set the temperatures essentially to just maintain whatever is in our or set the temperatures and rainfall to just mimic, just to be what is already existing in our MET file. So we'll change our change in maximum temperature to 0 degrees Celsius, our change in minimum temperature to 0 degrees Celsius, our relative change in rainfall to 0%, and leave the atmospheric CO2 concentration at 350 parts per million. So that sets up our first, or our baseline climate scenario. Now to do the climate change scenario, because we want to compare between the two, we're going to run these two simulations at the same time. So we're going to create a duplicate of our simulation. So right click on our simulation name and then create a duplicate of this node. Okay. Now what we're going to do is actually create a linked duplicate, and this is a very handy function. We'll get into what this enables us to do just in a second. So just check this box here, create linked duplicates, and create one duplicate of it. And notice here that our duplicate is in blue, not in the standard black. And if we actually expand it out, you see all the nodes in the simulation tree are also blue in color compared to our original simulation that is in black. And that's because we've created a linked duplicate. So what these links mean that is if we change anything in the original or a linked node, we'll actually change it in all simulations that are linked together. So if we say wanted to change our climate control, have a 1 degree increase in maximum temperature, and we did this in our linked or our duplicate simulation, if we click back on the original simulation, you'll notice that that's already changed it, already implemented a 1 degree change in temperature. So we'll just go and change that back, and we'll click back on the control or the climate control node in our link simulation and notice how it's changed back. Okay, so what essentially we've got here is two simulations, and if we change anything in one of them, we'll change it to the other one. But what we want to do is set up a simulation with a slightly different climate scenario. So right click on the climate control node in our linked simulation, our duplicate simulation, and go down the list here to select unlink this node. And once you've done that, you'll notice it reverts back to being black. Okay, so now when we change something in this node, it doesn't change it back in the original simulation. So now we can actually set up different factors in just to do with the climate change parameters of our simulation, while keeping everything else the same. And this is a very handy tool when creating lots of simulations where only one thing changes in them, say a fertilizer application rate or a sowing date, and keeping everything else the same. So it's essentially a very quick way of setting up simulation experiments with. So in our duplicate simulation or a linked simulation, we're going to rename it first of all. So right click on the simulation title, select rename, and this one we'll call 600 parts per million. Okay, expand it back out till you get to the climate control node. And in this case, we're going to set our change in maximum temperature to 2 degrees, our change in minimum temperature to 2 degrees. We're going to have a negative 10% change in daily rainfall. And our atmospheric carbon dioxide concentration we're going to set to 600 parts per million. Okay. Now, with climate change in APSIM, not all crops are set up to handle it. So notice here we're working with wheat. Wheat is set up to handle climate change or changes in specifically atmospheric carbon dioxide concentration. A lot of the crops actually aren't. So if you're working with any other crop other than wheat, oats, or barley with the climate control manager, and if that atmospheric CO2 concentration is set to anything other than 350 parts per million, your simulation won't work, it'll throw an error. So we can only do currently in APSIM, in APSIM 7.10, we can only do climate change simulations for wheat, oats and barley. Now we've set up our climate change parameters. We're just going to run these simulations. So select the simulations folder and click run. Great, our simulation ran. Let's just click on our output file node and we'll see here we've got a run of years with our outputs that we requested. So biomass yield, that's for it, and this is for our 350 parts per million simulation. We do the same thing for our 600 parts per million simulation. We also get a run of years or harvest dates and yields and biomass and other parameters that we've requested. But we want to compare between the two. So we're going to create a probability of exceedance plot, which will enable us to compare between the two. So click on the graphs toolbox down the bottom toolbar, select under the graphs folder, select or drag the probability of exceedance plot up and place it into the simulations folder. Once it's there, we can close off our graphs toolbox. We don't need it anymore. Expand out our probability exceedance node right till we get to the APSIM file reader. Click on Browse, and then select our two output files. So they're 350 parts per million and our 600 parts per million .out files. Click Open. Click back on Plot. Leave Y variables as probability of being above. Select the X variables box, make sure it's pink, and we just want to plot yield. Okay, and then if we click back on the probability of exceedance plot, we'll see here a plot showing the probability of exceedance yield for our two scenarios. And notice here they're actually quite similar. And in fact, there's actually some benefit from climate change in this case. Now that's quite interesting and might not be the result that you expected. And that's because if we go back to our soil setup, our initial water, and click on our initial water node, notice here that we're starting our simulation with a full profile, which probably isn't really correct for a future climate scenario because of increased prevalence of droughts. So expand out our 600 parts per million simulation tree till we get to the soil node and expand it out. And we're actually going to set up a different initial water status for our future climate scenario. So right click on the initial water node, and then we want to unlink this node as well because we don't want to change it in our baseline simulation. We just want to change it in our future climate simulation. So instead of it being 100% full, we're going to set it to 30% full, okay, to reflect the fact there's less rainfall, and hence that our fallows will probably be, will not store as much water. Okay, and this is actually a really important example of what we need to do when running APSIM or when doing any modelling scenario. We need to think through the full aspects of the scenario and make sure our simulation setups reflect what really would be happening in that case. Otherwise, we can get some nefarious results and probably make some incorrect conclusions. So now that we've changed our initial water in our future climate scenario, we need to rerun our simulation. So click on the simulations folder and click run. And then we can click back on our probability of exceedance plot to see the simulation results. Notice here this is probably a much more realistic and expected result here, where the yield under the future climate scenario, the 600 parts per million atmospheric CO2 concentration scenario, is lower than our initial or our current day climate scenario. So now that we've completed this simulation, we'll save it and we'll see you back for our next simulation topic.